Let's discuss about free radicals today. Free radicals are generally formed by homolytic fission when carbon is having 4 bonds. This bond is made up of 2 electrons and each atom is sharing its own electron. So you can say 3 bonds as it is 1 electron. Another atom also same thing, 3 bonds and 1 electron. So when 3 bonds and 1 free electron is present, then such kind of carbon radicals are called carbon free radicals. This kind of fission is called homolytic fission. The same you can expect in, for example, chlorine molecule. This can be done in the presence of sunlight. So you will get here 2 chlorine free radicals. Free radicals are given by generally a dot that is indicating the free electron. Same you can go with bromine molecule, 2 bromine free radicals. So we say HELPR. These help in formation of the free radicals. Here H means heat, E is electricity, L is light, P is peroxide, R is radical. Already if a radical is there, or a peroxide or light or electricity or heat, help the formation of the free radicals. Remember, helper helps. So our free radical, we will take basic carbon free radical. There are 3 bonds. 3 bonds means each bond 2 electrons. So number of electrons from the 3 bond side is 6 electrons. 1 free electron is there. So total number of electrons will be 7. Number of electrons around carbon atom will be 7. So less than octet configuration, octet is not completed. So you can say this is electron deficient molecule. 1 unpaired electron is there. So this is definitely paramagnetic in nature. Generally, carbon, when it is having 3 bonds, all these are given like this, and 1 free electron will be present in generally in a pure orbital. This is the pure orbital. This geometry is indicating this is sp2 hybridization planar molecule. Carbon with 3 bonds, 3 sp2 hybrid orbitals are used. 1 pure orbital will be there. This pure orbital is having 1 electron. This pure orbital is having an electron. Because of this electron, it is paramagnetic in nature. 3 bonds, they are in trigonal planar in shape. This is about the geometry. Then stability. Stability directly proportional to plus I, inversely proportional to minus I. Reason is very simple. Electron deficient, they are in need of electron, and we know that plus I groups support, minus I groups should not be there. So if any plus I groups are there, that is better. We'll see types. CH3 dot, this is methyl free radical, it's a primary one. CH3 CH2, it's a ethyl free radical, again primary one. CH3 CH3, this is isopropyl, the carbon is secondary carbon, so this is secondary free radical. Isopropyl. If this dot is present on the last carbon, that will be n-propyl. Here this is present on the middle carbon, which is the secondary carbon, so this is secondary free radical. Similarly, tertiary butyl, where a carbon atom attached with 3 methyl groups, it's a tertiary carbon having an electron. This is tertiary. So tertiary free radical. If you see the stability order, tertiary free radical is better than or more stable than secondary, primary, and least stable is CH3 dot. The order is very simple. It is having 3 plus I groups, it is having 2 plus I groups, it is having 1 plus I group. Here no plus I groups. More the number of plus I groups, more will be the stability. So this is obviously more stable. Tertiary is stable than secondary, than primary, than methyl. Coming to another one, CH2 double bond CH dot. As we were discussing, this is vinyl free radical, least stable. No resonance structures are possible here, so this is least stable. And moreover, the dot electron, that is unpaired electron, is present on the sp carbon, so it is not possible. CH2 double bond CH, CH2 dot. This is an sp2 carbon, you can say, and this can participate in resonance. So you can show a structure like this, CH2 dot CH double bond CH2. This is called resonance. Because of resonance, it is stable, and this radical is called allyl radical. Allyl is stable. You can take allyl as stable. The same thing you can expect in case of benzene attached group, which we call benzyl free radical, as we were discussing in carbocation. Same concept here. So because of this, a structure will be like this. I am showing one structure here. This will become double bond CH2. Here will be a dot, then this can go here, and then this can come here. So more number of structures are possible. In benzyl free radicals, as the number of structures increases, the stability also increases. So benzyl is stable, accepted. So allyl and benzyl are good and they are stable than vinyl, you can say. Vinyl free radical, least stable, no stability for this, but these two are good. We can't discuss any tropylium type of carbocations or cyclopentadienyl type of anions here. This we were discussing. I hope you remember this one. Stable carbocation, carbanion, but such kind of structures we don't discuss here. No special points are here like this. Next one, the overall stability, if you see, more the number of phenyl groups attached, pH3C dot, this will be more stable than pH2 CH dot. Two phenyl groups are there, pH CH2 benzyl free radical, this is stable than CH2 double bond CH CH2, that is allyl free radical. Allyl free radical, phenyl free radical are almost stable, but number of structures here will be more. 10 number of structures will be there. Here 7 structures, here 4 structures, here 2 structures. As the number of structures increases, stability will be more. After this, you can take tertiary, then secondary, then primary, then methyl. Methyl is also better than CH2 double bond CH dot. This structure we were discussing very similar in carbocations, except tropylium and cyclopropyl are extra there. Such kind of groups are not here. So this is overall stability order. We can take these kind of reactions in, for example, methane plus chlorine to form CH3Cl plus HCl. In these kind of reactions, we can take the help of this group. Here chlorine free radical is going to form in the presence of sunlight, and that is going to attack. So this kind of reactions are called free radical substitution reactions. Free radical substitutions are there, free radical additions are there. All these reactions we'll discuss in types of reactions. So this is about carbon free radicals. Okay, meet with